Hi, engineers. You are preparing for a QA or SDET job, but the interview you face is a different game. It often feels disconnected from what you will do on day one. Today, we will talk about why interviews do not make sense for real work, what interviewers actually want to hear, and how to prepare for the interview game so you can win it and then do the real craft later. Imagine this. You join a team and your first week looks like this. Read flaky test reports, stabilize CI, map critical paths, write a few solid end-to-end tests, build a couple of API checks, and maybe fix a data seed. None of that is reverse a binary tree in place. Yet your interview will still ask you to solve coding puzzles and theory questions. Let's decode that. Let's rephrase it in plain English so it really clicks. An interview is a risk filter. Companies try to predict if you can learn fast, reason in public, communicate clearly, and avoid expensive mistakes. They do not know your past team, your project constraints, or your shortcuts. So they rely on proxies, coding challenges, algorithm basics, test design theory, and a few tell me about a time stories. It is not the job. It is the audition. So what are they actually testing? First, thinking out loud. They want your plan before your code. Second, control of complexity. Can you keep a problem simple, avoid overfitting, and state big O without drama? Third, correctness over cleverness. Can you catch edge cases, nulls, empty arrays, timeouts, and race conditions? Fourth, tradeoffs. Can you pick between fast to write and easy to maintain? And fifth, communication. Can you explain your choice in one clear sentence? Why coding challenges for QA and SDD roles? Because automation is software. If you can write a clean loop, a small helper, and a readable condition, you can write stable tests. The puzzle is not your daily task, but it shows you can manipulate data structures, control state, and keep functions small. That reduces onboarding risk. What do they expect to hear on coding questions? Start with saying your plan first. Then, name your data structure. Declare your variables. State time and space. Run a tiny example out loud. And finally, code. Example script for a typical array filter task. I will use a forward right pointer to keep order. I scan once, write non-target values to the front, and return the count. Time O of n, space O of 1. Edge cases are empty array, all removed, none removed. That level of clarity is what wins the room. Now, let's talk about which coding topics show up for QA and SDT again and again. Arrays and strings. 2 pointers. Hash maps for counts and membership. Sets for uniqueness. Basic stack or queue. Simple tree traversals. BFS versus DFS naming. No one expects a red-black tree proof. They want clean loops and no off by one. So, how to prepare for the puzzle part without wasting months, you ask? Pick 20 classic problems and master them. Arrays. Remove element, move zeros, to sum, rotate, merge intervals. Strings. Anagram check. First unique char, frequency map. Maps and sets. Deduplicate, count, detect cycles like happy number. Trees. Inertor is sorted for BST, compute max depth, and validate BST by range. Graph basics, BFS level order. Time your thinking, not your typing. Now, the part that looks nothing like the puzzle but matters as much. QA and SDT decision questions. Interviewers will ask things like, how do you design a test strategy for a new feature? How do you reduce flaky tests? How do you test an API without a UI? How do you pick what to automate? Here is exactly what they expect to hear. For strategy, start with risk. Identify the critical path. Cover it with a thin, end-to-end smoke. Push most checks to lower levels with API and integration tests. Keep UI happy paths only. Mention the test pyramid and why the top is thin. For flakiness, classify causes. Timing issues, shared state, network, environment, and test data. Your steps. Add weights around system signals, not time sleeps. Isolate data per test, stub or mock external calls in lower layers. Add retries only around known flaky integration points. Track flaky rate, and quarantine until fixed. For API testing, define contracts first. Use status codes, payload schema, field validation, idempotency rules, and authentication. Add happy, boundary, and negative cases. Seed data or create per test. For what to automate, pick stable, repeatable, high-value paths. Avoid one-off UIs that change weekly. Keep noisy edge cases at lower levels. Explain the cost per test versus impact. Now let's talk about why interviews feel broken. Real work rewards context and iteration. You have time to read logs, try a fix, talk to a developer, ship a patch, and improve the pipeline next sprint. Interviews remove all of that. You get a timer and a blank editor. That is why they feel unfair. But remember, the goal is not to simulate your day. It is to sample your thinking under pressure. So we prepare for the interview game on purpose. Here is a simple plan. Step 1. Collect 5 short stories. A flaky test you diagnosed and stabilized. A bug the team missed that you found with a simple heuristic. A CI improvement that cut minutes off every run. A small framework decision that increased reliability. A conflict you resolved with data, and a quick experiment. Use the problem, action, result format. Make each under 1 minute. Step 2. Learn 4 sound bites. Test pyramid. Keep UI thin, push checks down. Risk-based testing. Pick tests by impact and probability, not by lines of code. Observability. Logs, metrics, traces. Tests are faster when the system speaks. Flakiness playbook. Timing, data, environment, network. Fix root cause, not symptoms. Step 3. Practice a coding routine you can say out loud. Read the prompt once. Repeat it back in 1 sentence. Propose a plan in 1 sentence. State time and space. Identify edge cases. Draft variable names before typing. Code slowly. Run a tiny example in your head. Print results. If broken, add 1 console log, not 10. Step 4. Learn interviewer translation. Here's what they mean. Why coding challenges for QA means showing you can write clean stateful logic. Why Cypress versus Playwright versus Selenium means showing trade-offs. Syntax, speed, ecosystem, parallel runs, and flakiness controls. How do you test without a UI? Means talk about APIs, contracts, and data layers. What is your biggest mistake? Means showing learning and a fix that generalized. Here's a little secret of what better not to do. Do not defend that interviews are useless. Smile and play the game. Do not start coding before you state a plan. Do not drown them in tool names. Say why you would pick one today. Do not claim 100% coverage. Say risk coverage and critical paths. Do not hide uncertainty. Say what you would measure or prototype. Let's script the coding challenge moment so it sounds strong. I will use a map for counts because lookups are constant on average. I scan once, update counts, then scan again to find the first unique. Time O of n, space O of n for the map. Edge cases are empty, spaces, and case sensitivity. I will normalize to lowercase. That is the level of clarity you want, even if the task changes. Let's script the QA design moment so it sounds strong. For a new payments feature, I start with the critical path. Create payment, capture, refund, and failure handling. I place a thin end-to-end smoke on that path. I push validation and most negative cases to API tests. I isolate test data per run. I add synthetic IDs for traceability. I gate merges on a fast subset and run the full suite on a nightly basis. I measure flakiness and time to detect. If flakiness rises, I quarantine, fix, and keep the gate clean. So, the final mindset to remember. Prepare for the interview, not for the job. The job will teach you context. The interview wants signals, clarity, structure, control, and trade-offs. The puzzle is not your work, but it is your stage. Treat it like theater. You know your lines. You know the beats. You know the exit. Quick checklist to close the topic. Prepare 5 stories. Have 4 sound bites. Practice a 10-step coding routine you can say out loud. Have 1-minute answers for strategy, flakiness, API, and tooling. Then relax. You are not proving that interviews make sense. You are proving that you can navigate them and then do the real work when it matters. That is the lesson. Prepare for the interview game. Win quickly, and save your energy for the craft you were hired to do. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.